Hello everyone, welcome to Leap, where you learn once and remember forever. In this video, we are going to look at one of the most interesting topics in mathematics. And this topic or this concept has its application in every other field out there. For example, recently, maybe not recently, but when COVID hit, right? The researchers soon after, very shortly, did come up and say that it was going to be a pandemic. Now, when they are announcing something like that, they need to have some kind of reasoning or proof or evidence behind it, right? Now, that's where exponential functions comes into picture. Exponential functions helps the researchers to identify the rate at which the pandemic was spreading. Now, once they know that, they will be able to say, okay, it is going to claim these many lives, probably it's going to worsen or whatever it is. And it's not just in the medical field, but it is also, for example, consider any businesses. In order to predict what their future profits might look like, and in order to maximize their profit, even businesses use exponential functions. Exponential function will tell the company how the company is growing, the rate at which it is making profits. Now, when you study that, then they can make adjustments and try to maximize the profit that the company is making. In order to work on the applications of exponential functions, you need to know the basics of exponents. So in this video, we are going to deep dive into the basics foundations of exponents, where we will cover what are exponents and what are the different types of laws of exponents. Now, once you know them, then it is easy to work on graphing and then transformations of the same functions. So let's get started. For those who are watching Leap videos for the first time, I am Deepika, a mathematics educator who tries to make maths AEAP, as easy as possible. Let's get into the video. To begin with, let's see what is an exponent or an index. Consider the number 5. And let's say you're multiplying this number 5 by itself 4 times. So how do you write it? So you can write it as 5 times 5 times 5 times 5, right? Now this is too long to write. Imagine if you were to multiply this 5 by itself 10 times, then you keep writing times 5 for 10 times, right? That's too long. Now this can be written in a simple form using a notation. Now that is basically 5 to the power of 4. Now this 5 raised to 4 has a name. So this 5 raised to 4 is called as power. So now within this power, you have parts. So you can see there is a 5 there is a 4 there, right? So this 5 is called as the base of the power, and this 4 is called as the exponent or index of the power. So this can be done for any number. So let's say if you have 11 multiplied by itself 3 times, so 11 times 11 times 11, that can be written in this exponential form as well. So what is the base? Base is the number that is being multiplied. So the number multiplied here is 11, and this 4 that we have written is the exponent. What is the exponent? The number of times the number has been multiplied by itself. So 11 is multiplied by itself how many times? 3 times. So you can put that 3 as the exponent. So 11 cubed. That's the exponential form. We'll try one more. So let's say you have the number 7 multiplied by itself 7 times 7 times 7 times 7 times 7. So you can see the base here clearly is a number 7, and it's multiplied by itself how many times? 1, 2, 3, 4, 5 times. So that becomes the exponent. So it is 7 to the power of 5. So this is basically the way we write a given product in exponential form. Now let's move on and see what are the different laws of exponents. There are certain rules that you follow while you're dealing with exponents. The first rule is the index law for multiplication. So let's say you are given 2 to the power of 3, and then again 2 to the power of 4. Now this rule is applicable only if you have the same basis. So this 2 and 2, the bases are same, so you can apply this law. Otherwise you can't apply this law, okay? So 2 cubed times 2 to the power of 4, the rule says when you have the same base and when you have multiplication in between, you can add the powers. So basically 2 to the power of 3 plus 4, that's basically 2 raised to 7. Well, it works like that, right? Because if you actually try to expand this further, 2 cubed can be written as 2 times 2 times 2, and this times I'm putting it here. 2 to the power of 4 is basically 2 times 2 times 2 times 2. And when you actually count how many 2's are there, you know there are 6 plus 1, 7 2's. So 2 to the power of 7. So instead of doing this long process, you're just doing addition of the exponents, and there you go. You get 2 raised to 7. Okay. This applies again to any kind of exponent, just that the base has to be the same. So let's say if you have 5 to the power of 4 times 5 to the power of 2, then the rule is if you have the same base and multiplication in between, you just add the powers, which is the exponent. So 4 plus 2, 5 to the power of 6. That's it. The generalized way to writing law 1 is a to the power m times a to the power n gives a to the power m plus n. Just that the a has to be same base. It's applicable only if you have same base. Now let's move on to law number 2. This is the index law for division. It works very similar to the previous case. So let's say you have 2 to the power 3 divided by 2 to the power 2, which means you have to basically subtract the exponents. So that's basically 2 to the power 3 minus 2, which is basically 2 to the power 1. That's just 2, right? Now, if you actually try to expand and see why this rule is true, we can try that too. This can be written as 2 times 2 times 2. And this division is basically over 2 squared, which is 2 times 2. Now, if you try to simplify this, well, we can cancel them out. If you're canceling them out, 2 times 1, 2 times 1, 2 times 1, 2 times 1, you're left with just 2, which is your answer, right? So instead of doing this the long way, you're just using the rule, index law, to get the answer directly. We'll try maybe one more. So let's say you have 7 to the power of 4 divided by 7 to the power of 3, then the rule is 7 to the power of, okay, it's the same number, so I'll just change it to 14. Let's say 7 to the power of 14 divided by 7 to the power of 3, then you just have to do 7 to the power of 14 minus 3. Again, remember, the bases have to be the same in order to apply this index law, otherwise you cannot. So 7 to the power of 14 minus 3 will give you 7 to the power of 11. So that's the index law for division. So the generalized way of writing that would be a to the power of m divided by a to the power of n will give you a to the power of m minus n. That's it. Now the third rule is index law for power of power. So that means you have, for example, 3 to the power of 2, and then you raise it again to an exponent, let's say 5. If you have this, then the rule says you just have to multiply the exponents on top. So that's basically 3 to the power of 2 times 5, and you get 3 to the power of 10. Okay? Now, we'll try to expand this and see why this works like that. So this can further be written as 3 squared is multiplied by itself 5 times, isn't it? So 3 squared times 3 squared times 3 squared times 3 squared times 3 squared. Now applying rule 1, all the bases are same, you have multiplication in between, you can add the exponents, right? So that gives you 3 to the power of 2 plus 2 plus 2 plus 2 plus 2, which is 3 to the power of 10, which is the same as your previous answer, right? Now, instead of doing this long way, this gives you a simpler answer. Now, we'll make a generalized rule for it. So the generalized rule would be, if you have, I'll write it here, a to the power m whole raised to n can be written as a to the power of m times n. That's your generalized rule for power of power index law. Okay. The next one is index law for products or brackets. Now here, base can be anything. It can be different or same. The exponents need to be the same. So make sure that it has the same exponents. Let's say you have 5 to the power of 2 times 3 to the power of 2. Then, according to the index law, they want you to keep the exponent the same and then multiply the bases. So 5 times 3 whole to the power of 2. So that's basically 5 times 3 is 15 to the power of 2. So 15 squared. So if we try to expand this, so that becomes basically 5 times 5, and this becomes 3 times 3, right? And then you can see you can club 5 and 3 together, make it 15, and then club this 5 and 3 together, you get 15. That's basically 15 squared. So that's the same, right? So instead of doing this, you can just directly apply the index law. Okay, we'll try some more. Let's say you have 7 to the power 4 times 2 to the power 4. Then you just multiply the bases and raise it to the common exponent 4. So 7 times 2 is 14 to the power 4. That's it. Now, the generalized way of writing the rule for this would be a to the power m times b to the power m equals a times b the whole raised to n. That's it. So this is law number 4. The next law is index law for quotients of fractions. This is very similar to the previous one. Again, the rule here is that it needs to have the same exponents. Only then you can do it. If you have 3 to the power, let's say 4, divided by 2 to the power of 4, then this can be written as, division is basically you can convert them as a fraction and write, right? So this can be written as 3 to the power 4 over 2 to the power of 4, and common exponent, you can raise it to a common exponent 4. So that will be 3 over 2 whole raised to 4. So that's basically the rule. So if we try and do the same with some other number, let's say 11 to the power 5 divided by 3 to the power 5, then this can be written as 11 over 3 and then raised to the common exponent, which is 5. That's it. Now, the generalized way of writing this would be a to the power m divided by b to the power m, where the exponents are same, base can be different. You can write that as a over b the whole to the power of m, which is basically a to the power m divided by b to the power m. It's the same thing. Okay, so that's law number 5. Now, the next law, law number 6, is the index law for zero index, which means if your exponent is 0, then the value of that power becomes 1. So let's say 6 to the power 0, that means the answer is 1. So let's say you have 6 to the power of 3 divided by 6 to the power of 3. You basically write that as 6 to the power of 3 over 6 to the power of 3, don't you? And we know that if you cancel these, you basically get 1, right? Now we are going to apply laws of index and then see if this works. Okay, this is one way of doing. The other way of simplifying this is 6 to the power of 3 over 6 to the power of 3. You can apply the second law of index, which says if you have the base same, you can subtract the powers, the exponents when you have division. So that gives you 3 minus 3, which eventually gives you 6 to the power of 0. Now this and this are the same answer for this question, right? So that is why anything to the power of 0 will always be 1. So even if it is negative 11 to the power of 0, that's gonna be 1. But you gotta be careful if your negative is outside and the number is just raised to the power of 0. Then that means negative will be as it is. 12 to the power of 0 is 1, so that's negative 1. That's your answer, okay? So the generalized rule for that would be a to the power of 0 is 1. So which means a is any number. You raise it to the power of 0, it's 1. And it applies for fraction as well, okay? Then we have one more index law, the last one, which is index law for negative index. Now this has a lot to do with something called as reciprocal. Now you need to know what's reciprocal in order to do this. So let's say if you have a number 2, the reciprocal of this number would be 1 over 2, because if you convert this to the whole number 2 in fraction, then it becomes 2 over 1. Reciprocal is you just flip it. So you flip the numerator to denominator and denominator becomes a numerator. So 2 over 1 becomes 1 over 2. If you have, let's say, 3 over 5, the reciprocal will be 5 over 3. This is the general meaning of reciprocal, okay? Now we'll be applying these reciprocals in negative index to make it a positive index. Now let's say you have 3 to the power of 7, okay? And let's say 3 to the power of negative 7. So what happens here is, this is basically 3 raised to negative 7. Now if I have to rewrite this 3 as a fraction, I would rather write it as 3 over 1 to the power of negative 7. Yeah. Now if I have to change this negative index to a positive index, I just need to take the reciprocal of this. So when I say reciprocal, it becomes 1 over 3 raised to positive 7. And you can bring down the 7 if you want. And that's 1 raised to 7 over 3 raised to 7. 1 raised to anything is 1. So 1 over 3 to the power of 7. Now, if it is a fraction, let's say you have 2 over 5 raised to a negative 3. Then the rules are the same. You take the reciprocal of this number, you get 5 over 2, and raise it to the positive exponent of negative 3, which is positive 3. That's it. Okay, so this is basically the rule for negative index. And the generalized way of writing that would be, if you have a to the power of negative n, we can write that as 1 over a to the power of n. Or we can write 1 over a to the power of negative n as a to the power of positive n. These two works the same. So that's about that. So these are the 7 different index laws that you need to know in order to work with exponential functions or any exponentials. I hope you were able to understand what are exponents or indices and their laws. If you like this video, please give a thumbs up. And please share this video with whoever you think this will be beneficial to, especially middle school students and senior school students. If you have any doubts or questions, please feel free to leave them in the comment section and I will get back to you shortly. In the next video, we'll discuss more about how to apply these laws into complex exponential questions and also about how to graph exponential functions and solve exponential equations. So until then, take care. Thank you for watching.